Welcome to this video on linear regression. In this video, we are going to talk about linear regression, and we are going to look at the process of finding the equation of the line of regression or line of best fit. In scatter plot, we are interested in looking at the pattern the points will show, and in this one, in linear regression, we are going to find the equation of a line that can model the given pattern, and the whole process is called the linear regression. The equation of the line is also called the line of regression or line of best fit, or sometimes called the least square line. So all these three names, they will suggest the single thing: line of regression, line of best fit, or least square line is the line or the linear model that describes the pattern that you see in the scattered plot. In general, this is the equation of the line of regression, which is y hat, or the predicted value of y, equal to ax plus b, where a is calculated using this formula and b is calculated using this formula here. So this is one way of writing the equation of linear regression, which is widely used. But there is also a second way of writing the equation, that is y hat equal to a times x minus x bar plus y bar, where x bar and y bar, these are the mean of the x value and y value in the scattered plot. So the line of best fit or least square line, or the line of regression, it passes through the point x bar comma y bar. That is, it passes through the mean of x comma the mean of y values. There are a few terms that we need to know in linear regression. The first one is the residual or error. Here I have the scattered plot. These points here, they represent the points in the scattered plot, and this line here, this is the line of best fit. Now, when we talk about residual, or sometimes referred to as error, is the difference between the observed value and the predicted value. For example, this is the observed value. For at D3, you can see, suppose this is the observed value. The predicted value, if you use the equation, if the equation of this line is y hat equal to ax plus b, if we use that line to predict the value over here, the value will be on the line. So this difference between the observed value and the predicted value, that is called the residual or error. So whenever you are asked to find the residual or error, your formula will be D equal to, let me change the color here, that is D equal to the observed value minus the predicted value. This will give you the residual or error. Okay. Next, the line of best fit. This line which passes through most of the point in the scattered plot, and which definitely passes through, we have seen in the previous slide, x bar comma y bar, or the mean of x comma mean of y. That is the line of best fit. A regression line, also called the line of best fit, is the line for which the sum of the squares of the residual is a minimum. So meaning of that is, you can see here at D3 that I have pointed, this is the residual. At D1, that is the residual. At D2, that is the residual. So for the least square line, if we find the sum of the square of this distance, so if I find the sum of square of all those distance, say D1 squared plus the second one, which is D2 squared, D2 squared plus D3 squared plus D4 squared plus whatever number of points are there, let's say Dn squared, this value, this sum must be minimum. Because the sum of the square of these distances is minimum, we say that this line is also called the least square line. So that is the line of best fit. Few more terms here. So here I have this scattered plot. You can see there is a line of best fit, and there is one point which is quite far from this line of best fit. So a point in the scatter plot that has an extreme x value or sometimes extreme y value, or both, or we can say that a point which is quite far from the line of best fit, that is called an outlier. So we see outlier in the data maybe because of the error in the recording when you are collecting the data, or some sort of biasness in collecting the data. Now this outlier, sometimes that can be influential. So influential point, an observation that is removed significantly, that if removed significantly changes our statistical measure. So some of the outliers we cannot remove from the data because it will significantly change the trend of the line. So those type of points that you see in the observation, that is called the influential point. So after we have the fundamental idea of the linear regression, we are going to work on one problem in detail, and we are going to explore every little thing that you need to know in this course from linear regression. We are taking single example, but we are exploring everything. So here is the first one. And in fact, we have the sub part on this question. A random sample of 9 statistics students produce the following data, where X is the third exam score. So these are the exam score, third exam score out of 80. And this one, that is your X, and this is your Y. X is the third exam score. Y is the final exam score out of 200. So here are the scores. What we have to do is we have to find an equation of the line of best fit using calculator. That's one thing, but let's go one by one. Let's do this one first. Display the data in a scatter plot. So we need to display this data in the scatter plot. So for that, I have the x-axis and y-axis labeled here. So along the x-axis, I am plotting the third exam score. And along the y-axis, I am plotting the final exam score. So the first one, we have 64, 175. 64 is here, so 175 should be this point. That's your first point. Next, we have 68 and 130. 68 is here. 130 will be a little bit above 25, so 130 should be this one. Then 70 and 185, this is 70, 185, this is okay, here it is, 150, so 175 will be there, so 185, quite close to 200. Okay. Next is 71 and 160. 71, little bit after this one, which is this one, 71. And then 160, 150 is here, so 160 will be a little bit up. Okay, a little bit up. That is 71, 160. Next we have 65, 126. 65 is here, and 126. 125 is here, 26 is a little bit above that. So 126 is that point, 65, 126. Next we have 74, 195. 74 is here, 195 is quite close to 200. 74, quite close to 200 is this one. Then we have 66, which is here, and when it is 66, it is 150, so it is exactly this one. And then 71, we have 160. 71, and then we have 160, which is a little bit above this. So 71, 160, we have already included that, so it's the same point. Then we have 70 and 155. 70, 155. 150 is here, 155 will be a little bit above that. So that is a scattered plot. So when you go from left to right, maybe there is a little bit of increase, but we don't know. We are going to check that. So display the data in a scattered plot. We did that. Then we have to find the correlation coefficient using calculator and interpret it. So now what we are going to do is we are going to input this data in calculator and we are going to find the correlation coefficient. In our TI-84 calculator, we go to Stat, then we select number 1, that is to edit. And then in list 1, we put the X value. In list 2, we put the Y value. So after we enter the data in list 1 and list 2, list 1 X, list 2 Y, we press Stat, then we go to Calculate, and then we press number 4. So in number 4, we have to tell where is our X list. X list is in list 1 or L1. My Y list is in L2. We don't have any frequency. If you want to store the equation of the line of best fit, you can store here. So I'm going to store that in Y1. So for that, we press alpha, and then this one, trace, and number 1. So number 1 is selected, Y1, enter. So my equation will be stored in Y1. Then I'll go down and hit calculate. So enter that. So after you enter, you'll get the value of R. So here you can see that your correlation coefficient R equal to 0.5223. So we are going to record that. So from calculator, let me write that. Okay, from calculator, R is equal to 0.5223. That's your R. So after you get the R, so we got this scatter plot, we did that. We find the correlation coefficient, that is R, using the calculator, and we need to interpret this. We need to write the meaning of this. When R is 0.5, we know from the previous video that there is a weak positive correlation between the third exam score and the final exam score. There is a positive correlation, that is, if you get good grade in third exam, there are chances that you'll also get good grade in the final exam. But we don't have very strong evidence to support that, but there is a weak positive trend. So we are going to interpret like that. What we will write is, there is a weak positive correlation between the third exam score and the final exam score. Okay, that is the first part. Now let's move on to the second part of the question. So we did this. Now in the second part, we are asked to find the equation of line of regression. So here we are asked to find the equation of the line of regression. If you remember, we stored the equation of the line of regression in our calculator. So if you grab your calculator, then if you remember, we stored that. If you remember, what I did was I went here, and over here I stored that in Y1. I press alpha, trace, and then number 1. So it is stored there. That's how I calculated before. So in order to find that equation, you go to Y equal to, then you'll see this equation. So equation of line of regression is 3.6831x, then plus and minus, that means minus 93.761. So let's write that result using calculator. So equation, let me write from calculator, equation of line of regression or line of best fit is, we write y hat, because this will give you the predicted value, okay, or the equation of line of best fit, y hat equal to, it was 3.6831x minus 93.761. So that is the equation of line of best fit. Okay, and after that, we are asked to interpret the slope, this slope, because this is y equal to mx and then b. So that is my slope. We have to interpret that slope in the context of the problem. So remember, this is your x value, this is your y value. So let's talk about slope. So we know that slope is change in y divided by change in x. So that is equal to 3.6831. If you multiply on both sides by delta x, you get delta y, or change in y, equal to 3.6831 times change in x. Now if we put change in x equal to 1, let's see what we get. Change in y is equal to 3.6831 times 1. So we will have change in y equal to 3.6831. So meaning of that is, if the third exam score, if your third exam score increases by 1, then your final exam score will increase by 3.6831. So if you do little well in the third exam, you will also do better in the final exam. So that will be our interpretation. By every increase in third exam score by 1, the final exam score will go up by 3.6831. Let me show this in the scattered plot. So based on the information, suppose this is the line of best fit. Now, if you tend to increase your third exam score by some value, let's say that is delta x, not delta y, then your final exam score, delta y, will also increase because you have the positive slope. Then when this is increased by 1, this value delta y will increase by 3.6831. So that is the meaning of the slope. That's why we said by every increase in third exam score by 1, the final exam score will go up by 3.6831. So that is the second part in our example. In the same problem, let's go to the third example here. Actually, third part. So always remember, we got the equation of line of best fit as y hat, that is predicted y value, equal to 3.6831x minus 93.7610. So that is the line of best fit. This will help you to predict the y value when you know the x value. So here we are asked to predict the final exam score for the student who received 67 on the third exam. So if the value of x, okay, if x is 67, we don't have 67 here. If it was 67, what will be the final exam score? We need to find that. So the predicted value, let's see. So we are predicting the final exam score for the student who received 67. So y hat is equal to 3.6831 times 67 minus 93.7610. So we just plug in x equal to 67. Now, if you use your calculator and try to find the predicted value, you should get, make sure you check it, you should get 153.0067. So they should obtain approximately 153 if their score in the third exam is 67. That is the meaning of that. So for any value missing here, we can easily predict the y value. Now the next one here, we are asked to predict the final exam score for a student who scored 90. Remember one thing, here you can see you have the minimum x value as 64 and maximum x value as 74. So you can predict the y value as long as the x value is within this range from 64, you can say domain, in the domain from 64 up to 74. But here we are asked to predict when x equal to 90. Also, the total point on exam 3 is 80 and there is no chance that somebody will get 90. That means in this case, since x equal to 90 is outside the domain, okay, outside the domain of this equation, as the maximum score for the final exam is 80, the prediction is impossible. That will be the answer for this one. You cannot make prediction because it is outside the domain of this. Or 90 is more than the maximum points that the student will get in third exam. X equal to 90 is outside the domain for this problem, as the maximum score is 80. So the prediction is not possible. Let's look at one more part on the same problem. And here is that. So same problem. If you recall, our equation was y hat is equal to 3.6831x minus 93.7610. That was the equation of line of best fit, or the line of regression was that. This is our x value, this is the y value. Now the question is, find the residual for x equal to 70. When you recall the definition of residual, it was d, the residual, is equal to observed value minus the predicted value. For x equal to 70 here, for x equal to 70, you already have the observed value. The observed value was 185, but we don't know what is that predicted value. So let's find the predicted value first. So for x equal to 70, the predicted value, or y hat, is equal to, we need to plug in x equal to 70 in this equation. So here we plug in 70. So it will be 3.6831 times 70 minus 93.7610. This implies, if you simplify this using calculator, you should get 164.0960. So that is the predicted value. So your residual will be equal to the observed value, which is 185 minus the predicted value, which is this one, 164.0960. So this implies D is equal to, so if you subtract this, use your calculator, you should get 20.944. So that is the residual. So if you get the residual as a positive value, meaning of that is the observed value, this one will be more than the predicted value. But if the predicted value is more, this residual will be negative. Okay, now the last part. Refer back to the scattered plot and find if there are any outliers. So we'll go back to the scattered plot. So here is the scattered plot, and we need to find out if there are any outlier. So outliers are any point that are significantly far from the line of best fit. If I look at my line of best fit, which is the equation y hat equal to 3.6831x minus 93.761, if this is the line, then you can see that most of the points are close, fairly close to this line, but there is one point which is a little bit far, which associates with 64, that is 64, 175. That should be the outlier because it is far from the line of best fit. So we say, by looking at the scattered plot, 64, 175 is an outlier because it is far from the line of best fit. Okay, that is the end of this video. Thank you so much for watching. I hope this is helpful.